Good evening. My name is Sanjay Kumar Today I am presenting my final thesis. Now I am sharing my screen. Yeah, I think the viewers can see my screen. My my thesis is that a Python-based cloud task scheduling on AWS and GCP. My thesis focuses on the building a simple and reliable and transparent cloud task scheduler. Focus on building a schedule that works across the both AWS and GCP without using a heavy orchestration tools. I want to explore whether the multi-cloud scheduling can be achieved using only Python serverless functions and management queue services. Then coming to the introduction, that background tasks are essential in almost of all applications. This includes the data processing, file handling, notifications, and many asynchronous workflows. Traditional scheduling systems are often complicated, expensive, or require deep DevOps skills. In my project, I designed a lightweight scheduler with a Python control plane that submits, tracks, and evaluates tasks running across the AWS, Lambda, and Google Cloud functions. Here comes the problem statement that the main problem I addressed in this thesis is that existing cloud scheduling solutions are too complex or vendor independent. Many small teams do not have to resource maintain Kubernetes or many other orchestrators. They often get locked into the single cloud provider. There is a clear need for a simple and vendor neutral provider for the model that works across the both AWS and Google Cloud. My thesis directly responds to this graph by creating the portal schedulers of handles by the task submissions. Coming to the primary research, these are my primary researches. My primary research involved hands-on development and the experiments. I implemented the Python control plane, deployed functions to AWS and GCP, and executed a real workloads. I tested CPU intensive tasks by input output based tasks and failure injection tasks during these tests. I collected data such failure latency, reliability outcomes, retry behaviors, cold start delays, and cost. Then coming to secondary research. The secondary research includes the detailed overview of studies related to serverless computing, scheduling algorithms, multi-cloud system designs. These studies shaped both my issues like cold start delays, with help understand the issues with the vendor specific difference, reliability patterns such as retries and dead letter queues. The secondary research key. Here are I will explain the studies I include in my literature review. The first study by Das et al. In 2020 presented the SCAD, a cost-efficient execution model for serverless workloads. And the second with the George 2024 compared the AWS and GCP cloud analysis performance since my project also AWS and GCP. The third study by Golek et al. 2024 provides a systemic review of serverless challenges, including the cold start delays, running time, and predictability. And the fourth one is Hassan et al. 2021 discuss the architectural patterns of serverless systems. Help me to design the clean execution of architecture using the quiz. The fifth study is Majid and Marin in 2023. The review of reinforcement learning based scheduling, even through my project, does not require AI. Then coming to the second research key studies two. The first I reviewed is Malwasky et al. 2021, which brand managed as AWS Lambda and Google Cloud Functions. This is extremely relevant because I really both provided the study enforcement my decision to perform across the cloud instrument. And the second one is Rusa et al. 2024, and third one is Van Buren et al. 2021, and the fourth one is Wasim et al. And 2024, and the fifth one is Van et al. 2023. And then coming to the research gaps. The literature shows that the all through the have studied serverless computing and multi-cloud challenges. These are very simple, reproducible prototypes that students and small organizations can reuse. Most using solutions depends upon the components and advanced workflow engines. Coming to the hypothesis. My hypothesis starts with a simple Python control plane using the serverless functions and managed queues can deliver the reliable, transparent, and portable scheduling across the AWS and GCP with the acceptable performance. Then coming to the system architecture. The architecture consists of a Python control plane with two main endpoints, submits and stats. Tasks are pushed into AWS, SQS, and GCP. Depends upon the configuration, AWS Lambda Cloud Functions can run the task to show the outputs in S3 and GCS. DynamoDBs and Firestorm maintains the task, the cloud with the Stackdriver record logs. Here with the AWS execution flow. In AWS, when a task submitted, it is pushed into an SQS queue. Lambda receives the messages, execute the task, writes the result S3 to update status in dynamic DB. Cloud watchlogs document each stage. AWS built in the retrieves and dead letters. Queues help manage failures and keep the system reliable. Then coming to the GCP execution flow. It's the in GCP the same task goes through the a cloud function is triggered. The performance the task writes results to GCS and updates Firestorm Stackdriver logs provides the observability. This flows the mirrors of AWS of demonstrate the probability. Here comes the key features. The system uses idempotent to prevent the duplicates, retrieve the logic for transient failures, back up the strategies to reduce the stress during the errors, and dead letter queues for repeated failures. I also use structural login as identify handlers to remove the transparency. Coming to research methodology, this research schedule methodology combines the secondary research highlights with the primary experiment. I studied the serverless challenges, the cold start effect, scheduling the patterns, and multi-clouded difference and literature based those insights. I designed my architecture, implemented, then the performed work. Then coming to the data collection, I collected data from AWS Cloud Watch logs, GCP Stack Driver logs, and the dynamic DB stats entries. The five store stats entries in the stock that outputs also restore latency. Then coming to the data analysis. Data analysis involved comparing the AWS and GCP performance under the identical workloads. I examined the latency